Hi viewers, in this video we will solve problem 1.14 from the book Heat Transfer by J.P. Hallman, 10th editions. Here is the statement: calculate the radiation heat exchange in one day between two black planes having the area of a surface of a 0.7 meter diameter sphere when the planes are maintained at 70 Kelvin and 300 Kelvin. So we have two spheres, and this is the other sphere that is maintained at a temperatures of 300 Kelvin and the temperature T2 that is 70 Kelvin. Between them there is a heat transfer taken place, that is radiant heat transfers. So we need to find that radiant heat transfer throughout the whole day if it is maintained at a temperatures of 300 Kelvin and 70 Kelvin. Okay, so the temperature T1 that is 300 Kelvin, what is the temperature T2 that is 70 Kelvin, and the area we also need to find the area of this sphere, that is 4 r square. So this r is equal to d by 2, and what is d? That is 0.7 divided by 2, so it becomes 0.35 meter. Now so the heat transfers is equal to Stefan-Boltzmann constants, area, and 4 power of the absolute temperatures. So what is Stefan-Boltzmann constant? That is 5.66 multiplied by 10 to the power minus 8. What is area? That is 4 pi r square, and r square is 0.35 square, multiplied by temperatures 300 power 4 minus 74. So after simplification this on the calculator, you will get the final heat transfer, that is 74.8 watt. That's our final answers. I hope you understand. If you have still any confusion, you can ask in the comment section. Thank you so much. Please subscribe my channel if you haven't subscribed yet.